So now we're going to talk about interpreting energy bills and how we go about calculating baseload. As we go through part one of this session, we're going to talk about what we need to do to understand energy bills, how we go about calculating baseload and energy use, and then how we go about calculating our baseload cost. Okay, so what kind of information does our energy bill provide us? Provides us with simple things like how much electricity did we use, how much gas did we use. Depending on where we live, we might have our water consumption rolled into there. If we're in a commercial situation, we're looking at commercial energy bill, we could be looking at demand charges. We should have a cost per therm as well as cost per kilowatt hour, and whatever the cost is for our water usage, if that appears on our bill, as well as what our sewer cost is, if that's also part of our rolled up utility bill. Some municipalities actually generate their own power, and they provide power to their customers, and as a result, things like water and sewer will also appear, sometimes even trash, will all appear on the same bill. What we're going to do as a group here is we're going to take a look at a picture. The next picture is going to actually be a utility bill. And we're going to look at that utility bill. We're going to look at the kilowatts that are being used, that have been used, the therms that have been used, look around for the service charges, look for the cost per therm as well as the cost per kilowatt hour. On this utility bill, you'll notice under electrical service, and if you have your own utility bill in front of you, take a look at that. And you'll notice that we have a previous reading and a current reading. We take the previous reading, or the current reading, we subtract the previous reading, and that gives us the amount of either kilowatt hours or therms that were used between the two readings. We also have a cost. Now, sometimes the utility bill will include the actual, this is what you're being charged per therm per kilowatt hour, okay? There's also other charges on these bills. For example, we have our usage charge, but there's also an interstate pipeline fee, as well as other service charges. And typically, if you look on the back side of the bill will have the explanation for the various different charges. For example, the interstate pipeline fee is what this particular utility company pays to have the gas delivered to their customers. Now let's talk about baseload. First off, what is baseload? Does anybody know what baseload is? Baseload is the amount of energy, either gas or electric, that's used consistently throughout the year. And each one of those baseloads, whether you be an electric baseload or a gas baseload, has a primary baseload appliance. For gas, your primary baseload appliance would be your water heater, right? Because your water heater runs all year round. Your furnace doesn't. Okay? Now, on the electric side, what would be our primary electric baseload appliance? Our refrigerator, right? Now, included in our baseloads are things like lights, okay? And when we do our baseload calculation, we'll show you how all those things work together. But basically, our refrigerator is our electric baseload primary appliance, and our water heater is our gas baseload appliance. And of course, that's in a house that has gas to do heating with, right? And has a gas water heater. How do we actually go about calculating baseload? First thing we have to do is gather at least a year's worth of bills. Once we have a year's worth of bills, then we're going to rank the months by usage. Once we've ranked the months by usage, then we're going to select our base load months in kilowatt hours or in therms. Okay, so we have to do it for each. Okay, so we rank both our gas months and our electric months, and then we pick our baseload months for gas and our baseload months for electric. And we're usually looking for anywhere from 3 to 4 months, depending on where we live. Then we determine the average monthly baseload, multiply that by our cost per kilowatt hour, or cost per therm. Let's take a look at an example of this. Take, for example, the joules. This slide is a listing of the joules usage in both electric and gas for most of 2007, a little bit of 2008. What we've done is we've looked at each one of these months and we've ranked our kilowatt usage. The highest kilowatt usage months we've marked with a 1. Lowest, 12. So their highest usage in kilowatt is 720 kilowatt hours. The lowest is 300 kilowatt hours. Then we went through and we did the same thing and we ranked our gas. The highest usage was 250 therms in January. That makes sense, right? And then our lowest month was 15 in July. Middle of summer, beginning of summer, okay? Yeah, that makes sense. So everything is in order. So now what? The next thing we do is we're going to pick our baseload months. Now, we're doing the gas calculation in this slide, but you'll notice something. Didn't we say July was the lowest month? But July is not on this chart. As a matter of fact, the second lowest month, which was August, is also not on this chart. Anybody got a guess? Why not? Take a look at this. If we look at the 11th and 12th month, we see 15 therms and 20 therms. Our next closest value is 50 therms. That's quite a discrepancy. So if we're looking at a set of bills and we see this kind of discrepancy, we want to start asking questions. So let's just say that we were at the Jules house and we asked the Jules, you know, I was noticing when I was looking at your bills, I saw in July and August, you had unusually low gas bill. Can you tell me about that?
We went on vacation.
Mm-hmm.
We were on vacation. We were in the Bahamas for 2 months. Or we were in Alaska for 2 months, right? Oh, okay. That's not normal. That's what I'd say is it's not normal to go to Alaska. It's normal to go to Alaska. But the bill is not normal, okay? So we're taking those 2 months and we're going to set those 2 months aside because they are aberrant. If you look at the other months, you look at June, May, September, April, we see 50, 55, 60, 70. Those are much closer together, percentage-wise. Much smaller percentage of difference than between, 50 and 15. Okay? All right. So we take those 4 low months, okay, throwing those 2 months out. We take the next 4 months, we add them together. And so we find out for the baseload months, we use 235 therms. Then we take and divide that by 4 because we want to find out what the average is. And we discover the average monthly baseload is 59 therms. So then we take that 59 therms and we multiply it by 12 so we can see what the baseload is across the entire year. And we use, the joules anyway, they use 708 therms a year in their baseload. We take and multiply that by $1.50 a therm, and we find out that they spend $1,062 a year heating water for their house. It's a lot of money, isn't it? Baseload, because it's so persistent, it's valuable to take a look at. Because if we have an unusually high baseload amount that we're paying or usage, then we want to start taking a hard look at baseload appliances. Because normally, a water heater would not be a good investment. However, if you're in a 10,000 square foot house with a family of 6, 7, or 8, and they're using a lot of hot water, it might pay to look at some alternatives for heating water, such as an instant hot water heater, a tankless, or solar, or under sink instance, right? Under sink tankless. We have to run the numbers because the initial cost may be higher, but the actual usage or the amount of energy that we use could allow us to pay for that additional higher cost.
And how long does it
Okay, and then we have the financial tools. We have simple payback, we have annual return, we have return on investment, SIR, savings to investment ratio. Okay, we now have those financial tools to evaluate whether or not it makes sense to take our 62% water heater and replace it with a 92% tankless, 92% efficient tankless. Okay, so we just use those tools. I'd like you to first, on page 62, I'd like you to rank all of your electric months, and then I want you to rank all of your gas months, 1 being high, 12 being low. And then once you've done that, I want you to pick the 4 lowest electric months, write in the months and the amounts, calculate the total, find the average, find the yearly usage, and then we're going to multiply by, we're going to go 22 cents a kilowatt hour to calculate our base load for electric. Understand that unless you're dealing with extremes, okay, that's when you're going to throw numbers out, okay? So we're looking at when we go from 20, when we went from 20 to 50, we saw more than twice as much energy being used. Okay, that is significant. So if we look at, for example, the low in this case is 269. In order to see the same kind of jump, that would be, the next one would be somewhere in excess of 500, right, kilowatt hours, to see a 100% jump. Okay, do you see a 100% jump happening anywhere? No. Okay, so when we see 25, 15, 25, 30% increase between months, that's not that's not significant enough to tell us to say, hey, we need to either start asking questions or throw this out. Now, if that one was 269 and then we saw 340 and then we saw, 800, 900, 1,000, okay, yeah, now we're talking about, yeah, we need to start talking about throwing these numbers out. And you talk to the homeowner and you ask the homeowner, was there something special going on those 2 months? And they say, yeah, I don't know, we were here, we were on vacation, everything was normal. Then in that case, you'd include them. Because chances are, if that's the case, if that's normal, then every year in June and July, that's their energy bill. Right. Base load and seasonal load, right? In the wintertime, we have a seasonal heating load, and in the summertime, we have a seasonal cooling load. The reason why we don't just average the whole year is that if we average the whole year, it would include the seasonal loads. And consequently, we wouldn't have an accurate base load measurement. That would simply be our average usage for the year. let's just look at these two charts again. Seasonal versus baseload, right? If we look at seasonal load, we can see how in the winter months we have higher gas usage. That higher gas usage represents our seasonal load. But if you look at those 3 or 4 months that are down in that saddle, if we just kind of extend it out both directions and cut off all those peaks, that would be our base load. So even though our base load is a significant part of our energy usage, it's really that seasonal load that we want to focus on, because if we can drop that seasonal load, that's where we're going to have the biggest effect, right? But being able to calculate base load allows us to also calculate the seasonal load, because now we drop the base load out and what's left is seasonal load. Okay? Same thing happens on the other side with electric usage. Now, when you look at this chart, you see that there's not the big spike like with the gas. That could mean a couple of different things. What might this mean? What might this mean when you don't see a really big electric spike during the winter? What might that believe? Could be the location, that there's not a big temperature swing in the summer. Somewhere up in the mountains, somewhere up in the north, where they have heaters, but they don't have coolers or air conditioners and that sort of thing. Yes, we could have electric water heater instead of gas, but we're not seeing a big spike in the summertime. Maybe they have AC, but they don't use it. Or they're using something like a whole house fan or an adaptive cooler, right? Which doesn't use as much energy. You're seeing a little bit of spike, right, during the summer, but it's just not huge like it would be if they were using air conditioning. All right, so let's wrap this up. What energy use is included in energy base load? What's our primary electric base load appliance? Refrigerator. How about gas? Our primary water heater. Very good. How many months do we use to calculate our annual gas usage? 3 or 4? 3 or 4. Okay. And when I say 3 or 4, remember, let's head back up into the mountains again. We're up in the mountains. Guess what? Our heating season is longer, right? So that those peaks get bigger and that valley gets narrower, and we might end up in a point where grabbing 4 isn't practical. We really want to just grab 3. So calculating base load shows us the seasonal load. Both of these figures help us identify the areas that have the greatest potential for savings.